All right, good day. I believe your day has been great. Okay, so we'll be looking at absolute and conditional convergence today. It's like a two-in-one topic. So we start with the first part of the topic, which is what? Absolute convergence. All right, so before we do that, so let's look at what is the definition for absolute convergence. All right, so let me quickly write something down here for you to see. Okay, so the let me start by saying series the series A sub n converges converges absolutely converges absolutely if if the value of the absolute value. All right, so when you see these two lines, it means absolute value. Is that okay? The absolute value does what? Converges. All right, so that is the definition of absolute convergence. That is, the series A sub n converges absolutely if the absolute value converges. All right, and recall that a series is said to converge if the sequence of its partial sums approaches a finite limit. All right, when we say finite, that is, you will get a particular value as the number of terms increases without bound. All right, and of course, on the other hand, a series is said to diverge if the sequence of its partial sums does not approach a finite limit as the number of terms increases without bound. All right, so what the key thing here is that the series A sub n converges absolutely if the absolute value of the series also converges. All right, okay, so for you to have a very clear understanding of what I'm saying, so let's take a look at an example. All right, so example. So okay, let's say verify that the summation, that is an infinite summation of n is equals to 1. We have minus 1, the power of this all over n to the power of 2. So they say we should verify if it converges. Verify it converges. All right, so how do we solve this? From our previous classes, I believe you can still remember P series. All right, so first thing first, okay? So what are we going to do here? So we now write, remember, the series converges if the series converges absolutely if the absolute value converges. Okay, so what you're going to do first is you write sigma, which is the summation sign. This is the summation sign. Good. We say n equals to 1. That's to infinity. You put the summation sign. This is the absolute value. So we want to find the absolute value of an now. So we want to find the absolute value of this to the power of negative 1 all over n raised to the power of 2. So the absolute value of this will give us what? To give us this series. To give us this series as it goes to infinity, n equals to 1. The absolute value of this will give us 1 over n to the power of 2. So when you see this, immediately you see this, you know that this is a P series. All right, from our previous class, you understand what I mean by P series. All right, let me just quickly write something at this corner for you to understand a little bit better. All right, so let me just have a box here for you. Let me use another ink for you to get what I'm trying to say here better. Here, let me use red. Okay, so let me just squeeze some stuff here. Recall, when we talk of P series, when our P is greater than 1, that is the value of your P, that means it converges, and of course, when your P is less than or equals to 1, all right, it diverges. Less than or equals to 1, it diverges. converges. So let's just have this in mind as a reminder. All right. Okay. So now let's proceed to take a look at what we've got. So let me just go up a little bit. So let me go back to my ink. All right. Good. So now, like I said, when you take a look at this, you see that this is a P series. All right. This series is a P series. So that means we now say our P, when you take a look at this is a P series. Our P equals to 2. And of course, when you look at this, you know, P is greater than 1. And from what I just squeezed here, when your P is greater than 1, what does it mean? It means what? It converges, right? Because our P is greater than 1 by P series, then it does what? You know, it converges, right? Yeah, by P series, then it converges. All right. So just to make it look a little bit better, I cannot say therefore this series in the infinite series, you know, as it goes to infinity, that's what I mean by infinite series to the power of -1 all over n to the power of 2 converges absolutely. Now, why? Because that will be the question that will pop up in your mind. Why is it converging absolutely? Remember, if you take a look at the rules stated at the top here, just written here from the definition that this series A sub n converges absolutely if the absolute value converges, right? And of course, when we find the absolute value from this part, you can see the absolute value of these gave us 1 over n to the power of 2. So from there, so when we now use P series on it, we saw that the series converges. So, and according to the definition, this series AN converges absolutely if the absolute value converges. You know, when we find the absolute value using P series, we saw that it converges. So that means this series also converges absolutely. Is that clear? Good. All right, so now let's look at the second part of this topic now. The second part talks about, if you take a look at it, it's talking about what? The conditional convergence. So let's take a look at conditional convergence. When do we say a series converges conditionally? All right, so let's take a look at that real quick. So let me write that here. Let me use another ink just to differentiate what we are looking at. Is that okay? Good. Let me just make use of green this time around? Good. Let me use green. Okay. So I have my conditional convergence. Conditional convergence. All right. Convergence. Okay, good. All right. So an infinite series converges conditionally if the series A sub n converges, but the absolute value the absolute value diverges. All right. So that is the condition. Okay, let me just write that down as the definition for conditional convergence. Is that okay? So let me quickly write that. An infinite, you know, when we say infinite, it moves to infinity. An infinite series, A sub n converges conditionally if, right, if the series converges, but the absolute value of A sub n diverges. All right. So if you take a look at it very well, when we talk of the absolute convergence, both of them converges. But when we have one converging and the other one diverging, then it is a conditional convergence. Is that okay? So now let's take a look at before we proceed, and there's another thing you need to know about this one. All right. So it is in conditional convergence that we can apply what we call alternating test. All right. So and there are some conditions to meet before we can make use of an alternating test. Right. So it must be that when you are given the series, the an must be positive. That is, the term an must be positive, decreasing, and converges to 0. All right, so let me write that down. Conditions that must be met, using alternating test. Using alternating test, alternating tests, the conditions, the conditions, conditions are okay. So first one is that an an must be positive. That's the first part. It must be what? Positive. An must be decreasing. As you move from one term to another, term an plus 1 must be lesser than term an, right? So an must be decreasing. And then by the time you apply, you find the limit as it approaches infinity, it must converge to 0. So that means by the time you take the limit, you understand? So by the time you take the limit, the limit as n approaches infinity of an must be equals to 0. So these are the three conditions that must be met using alternating test to test for the convergence part of it. So, and of course, by the time the limit of an as n approaches infinity is equals to 0, that means it converges. All right, that is converges to 0. Or let's just say converges, right? That is, it converges, right? So these three conditions must be met when you are using alternating tests. So if all these three conditions are not met, then the series is not a conditional convergence. It will not be conditionally convergence. Is that okay? Remember, the series an or a sub n converges conditionally if a sub n, the series a sub n converges, but the absolute value of the series diverges. All right. So now for the absolute value part, by the time you make use of your P series, you are expected to get the series supposed to diverge. If it diverge, then it's the conditional convergence series. Or if it does not, if both of them converge, that means it is an absolute convergence. Are you getting what I'm saying? So that means using alternative, like I said, two things will be done for the series an. An must be positive, must be decreasing. When you take the limit, it must be equals to 0, that is, it converges. Then for the absolute value you apply, you find the absolute value using your P series, it must give you divergence for it to be conditionally convergence. All right. Okay, I've been saying a lot of things right now, so let's take a look at an example for a better understanding of all I just said. Is that okay? All right, so let me just go down a little bit and write the example. All right, so maybe I should just use another color for the example. Let me use color red for the example. All right. Okay, cool. All right, cool. So let's now take a look at that example. Example. All right. Okay. So the question is show that the following series converges conditionally. All right. So the question is show that the following series converges conditionally. All right, so and what is the series? So now let me write a series here. It's an infinite series. As n equals to 1, we have our, all right, n minus 1, then we have 1 over n to the power of 2 over 3. Is that okay? Cool. Now we have this written down. Is that okay? Cool. Cool. All right, so now that we have written the question, so I know, okay, the question is not completely written yet, so let me just they say it's equals to 1 over 1 to the power of 2 over 3 minus 1 over 2 to the power of 2 over 3 plus 1 over 3 to the power of 2 over 3. Then you can see the way the signs are alternating, right? The next one is what? Minus 1 over 4 to the power of 2 over 3. All right? Cool. Now, so then we have a plus, like I said, it's still infinity, continues like that. So how do we solve this question? It's very simple. So let's write solution. Remember, so we have to meet the 3 conditions for using alternating test. All right. So by alternating test now, so let me start by saying by alternating test. So let's look at it if all the conditions are met. By alternating test, so let's now itemize what we've got there. So let's look at it. Do we meet all the conditions? So, and of course, when you find the absolute value of this series, let me just go down a little bit, right? Okay. So when we find the absolute value of this series that we have right here, we now see that our an, when we say an, I'm referring to this part. That will be our absolute value. Is that okay? All right, good. So by the time we find that, that means our an or a sub n is equals to what? 1. The absolute value of that will be 1 over n to the power of 2 over 3. All right. So, and of course, if you look at it, this is positive. A is equal to this, so that is this term. All right. If you look at them one after the other, you can say, so that is these terms are positive. The positive term. Take a look at it. Is a what? It's a positive term. All right. So that's one of the conditions. All right. So when as you look at this sequence, one after the other, this is series, right? So if you look at each of the term, you can see, look at this, look at this, look at this. You will observe that you observe that 2 to the power of 2 over 3, 1 over 2 to the power of 2 over 3 is lesser than 1 over 1 to the power of 2 over 3. So also you observe that 1 over, look at what I'm talking about. You observe that this one here is lesser than this. So also 1 over 3 to the power of 2 over 3 is lesser than 1 over 2 to the power of 2 over 3. You take your calculator and divide it, you see that it is lesser. All right. So that's another condition. All right. So we can now say that, all right, so we can now say that 1, let me just pick the third one. All right. I can say 1 over 3 to the power of 2 over 3. You can pick any of the terms and compare them. You can pick the second one and compare with the first one. You can pick the third one and compare with the second one. So you can see that 1 over 3 to the power of 2 over 3 is lesser than 1 over 2 to the power of 2 over 3. All right. So that is, it's decreasing. So let me write that. That is an, that is the term an, it is decreasing. Sorry about that. Decreasing. All right. Decreasing. All right, cool. Now we know that it is decreasing. Then the third condition that we need to look at now is that if we take the limit, right? You take the limit of the term an, which is what? 1 over n to the power of 2 over 3. If you take the limit, will it give us 0? So let's take a look at it. So now from here, you see that the limit as n approaches infinity of an, right, is equals to what? The limit as n approaches infinity. What's our an? 1 over n to the power of 2 over 3 will be equals to what? 0. What does that mean? That means the series converges. Right? Right? So looking at all this, since all these three conditions are met, you cannot say since all the three conditions are met, all right, met, then the series converges by the alternating test. All right. So, and you know, when you are trying to find conditional convergence, right? You have to first of all apply your alternating test to it. After the alternating test, then you now find the absolute value, apply your p series to it, and see what you're going to get. All right. So now these three conditions are met. So that means an converges. Remember, an converges, but the absolute value of an will diverge or must diverge before we can say it converges conditionally, right? Okay, now we've been able to establish this. So that's the first part of the question we've been able to look at. So now let's find the absolute value now. So by the time we apply our absolute value, so let's see, what are we going to get? Is it going to diverge? Is it going to diverge? So let's check that out now. Okay, all right. So we can now say, however, the positive series, you know, it's an infinite series. The positive series, by the time we take the absolute value, like I told you, positive series as n equals to 1 over n to the power of 2 over 3 is a p series. I believe you can remember from our previous class how to identify a p series. So when you have like 1 over n to the power of something, that's a p series. Is that okay? Good. So from here, we were able to see that this is a p series. So since this is a p series, and of course, you can remember when we're looking at the absolute convergence, we already know the conditions that p series also needs. So that means our p here is equal to what? 2 over 3. Equals to what? 2 over 3. And of course, you know that 2 over 3 is less than 1. Going by the condition, that means that means the series, the absolute value, that means the series diverges by p series, you know, you have to state what you use for you to know that it diverges. All right. So now that the key thing we want to apply, the conditions have been met. All right. So then we can now conclude that, okay, since what we got, we were able to satisfy the alternating test conditions. We're able to also, by using P series, we got the absolute value to diverge. So thus, can I say thus, the infinite series n equals to 1 to the power of n minus 1 over n to the power of 2 over 3 converges conditionally. All right. So that's how to know if a series converges absolutely or a series converges conditionally. So don't forget the key part there. All right. So we've been able to establish that the conditions for an absolute convergence is that what? If you take a look at it, you see the series converges absolutely if the absolute value also converges. But for conditional convergence, the series converges, whereas the absolute value, we do what? We diverge. All right? The absolute value, we diverge. Hope you have learned something from today's class, right? Thank you for watching. Have a nice day.